Just waiting for others
राज
to
भाई।
be. Yeah, just waiting for others to join in.
हाँ हाँ। हाँ हाँ, अरे मैं यार ये कह रहा हूँ, वो साला वर्क स्पेस वो मेरा इंपोर्ट तो हो गया, लेकिन मैं ढूंढ नहीं पा रहा हूँ वो साला प्रोजेक्ट है किधर। मतलब इंपोर्ट हो चुका है वो।
अरे प्रोजेक्ट तो वही है भाई जहाँ तुमने बताया था।
अरे यार वो मैंने इंपोर्ट इंपोर्ट सब कर लिया, अब वो ब्लैंक स्क्रीन है, समझ नहीं आ रहा है साला कहाँ से मतलब कहाँ से देखूं वो सब जो नॉन मेवन वाला है।
I'll tell you. मैं बता दूंगा। I'll help you.
उस चक्कर में मेरा काम रुका हुआ है थोड़ा।
I'll help you.
ठीक ठीक।
Hi, Shali. Just waiting for Padmani also to join in. The Windows 8 behaves weirdly for me. So whenever I take session from Windows 7 laptop, that was good. Whenever I start it from Windows 8 laptop, it always a problem, at least once. Okay, so the file is created, and let's if we look at the file was created at the output directory, and if you look at this file which is created over here, Hadoop fs minus ls, and if I'll open this file, you won't be able to see anything. That's because that's a sequence file, and we can't. That's not exactly a text file. But you can see while this file is written, I've also printed few things with the file that is nothing but the record position of the file. So if you look over Hadoop fs minus cat, oh I gave ls, sorry. So see, the file is really not readable for us, but because it's a sequence file. But so it's nothing over there. So now if I say Hadoop fs minus, so how to read it in the Hadoop? You can just say text, and you can read it. So see, the file had only the key and the value. So this is the key and the value kind of thing which we created over here, which we gave the key is nothing but 0101 kind of thing, and the value is the value. So this is what we created, and this is the file. And over here I've just printed the block locations also, including the key and value there. So now let's look at the beauty of the file. So how to read it? There's a Java program also which I've created to read it, but I've just read it using the minus text command. If you can see minus text over here, and I can read this file with the help of minus text, which is already available in Hadoop. So is no one able to hear me, or is just Padmini who is not able to hear me? Puneet can hear. So Padmini, just cross check at your end if you are not able to hear me, because others are able to hear me. Okay, so this is how we can read the file, or you can use the Java code also to read the file. Now let's look at the beauty of this sequencing. Okay, so what I'm doing over here is I am saying my reader to start reading from this location in the file. If there's a start of block, I can easily read it. But if it's not a start of block, I will not be able to read it because my reader cannot understand the record format, because the record format has something called header, which talk about the format of the record, how to read it. So if it's not the start of a block or a record, it cannot read it. So let's give some position, let's say 4030. So it will be able to read that. Padmini, can you hear me now? So see, it read that and it printed key in the value pair 6910 big fat hen. So what we gave was 4030, 4030, 4030. Okay. Now if I give somewhere in between the records, say something like this, it will give me an error because it cannot now start the start of header, and if it cannot find the start of the header, it cannot read the file because it do not know what is the kind of record. So let's use it. Okay, before that, let me use this reader to read the file. And there's one more thing which I've done for you. Let me show that thing. So while I'm so while I'm reading this file, I've not only read the file keys and value pair, I've also printed the location of the blocks. Also, at some places you can see the stars. So these stars are printed by this reader, which has read this file, and these stars are nothing but the position at where our sinks are seen. So if you look over here, at some places you can see we have sync pointers. So these sinks are marked as star over here. So what this will help up is now if I try to read it with the help of these sync pointers, I can start reading. So now let's give, or let's give something else. Let's give this one. So this is in between the block. Okay, so I have to use a different file that is using the power of seek. So let's give 0, that is in between the block. So now you can see that it will, whichever you seek or sync, there are two files. Sync, that is sync sy and sync text. So it gave an error while I was reading from in between the file. I've used the older file only over here again. So now I'll use a new file where I'm trying to do sync. So if it's not the start of the header, I am trying to sync it over here. So this will very easily move your pointer to the position where you want, where there's start of a record. So if I give you an example, if you remember the audio players 10 years down the line, where you use the cassettes, two-sided cassettes, and if you wanted to listen some song, you would have done rewind forward till the time you really reach your song. But with the help of CDs, you can just say next, and you can really switch over to next song. But with those audio those cassettes which had long, magnetic tapes, you have to do rewind forward because they do not have these kind of sync pointers. So this sync pointer really helps you to start from a start of a block. So now you can see it started reading from here. 1, 2, 3, start from 15. However, I gave the position somewhere from here, 3740. So this is the power of these files. You can start reading from the start of a block even if you lost somewhere in between. Similar to your cassettes and CDs. Does it make sense?
makes sense. Thank you.
Okay. So map files are how 3470 start of block. So 3470 is not 3740 is not the start of a block. 3740 is not a start of a block. So you can see 3740 is somewhere in between over here. I gave a position somewhere in between, but still it read this record because this was resynced at this location, sync was at this location. The star, which is a spatial symbol which I printed from a program that is displaying the sync pointers in your file. So and when I use without sync code, that gave me an error because it was not able to really found the logical start of a block. Oh, sorry, record. Make sense? So it will start from the position where your sync pointers are, and the star over here is nothing but a sync pointer. That is this thing, this sync pointer. Map files are similar to a sequence file, but only difference is they not only contain your data, they also contain a map to the data. So let's create one map file, and that will give you a quick glimpse of map file. So I'm using the same program, but I'm creating a map file, and the records are again same 1, 2, 4, buckle my shoe, same rows, same records are repeated again and again 100 times with key and value pair. And before that, I have to delete this. Oops. So now it will create two files. One is a sequence file and one is an index with your file. And index with your file is nothing but pointing to the location where your keys lie. And it will contain only some keys, not all the keys. So this will not be an extensive map, a map with your data. This will be a smaller set of the map. And based on that, it will just try to figure out where start reading from. So let me open it and then it will show you. So let's look at this. Hadoop fs minus ls. So previously the file was created by the name of output, but now there's a directory created by the name of output, and there are two files in this directory. One is your data and one is your index. So Hadoop fs minus text, and this is your data. Same data. Same data, and the location of these things. And there was one more thing, was the index. So see, it only contained the key and the corresponding location of the only few keys. So if I give key somewhere in between them, so it will start reading from there and it will figure out that key after that. So this is useful if you want to do quick figures over the sequence files also. Make sense? So this also contains index with the file. Similar to a sequence file, but it also contains index with the file. Interesting files.
And which?
Yeah, go ahead.
So which class were you running at that point? If you go back to Eclipse, what was the file?
Okay, so this is the map file writer and sequence file writer and readers.
Okay. Okay, thank you.
So a pretty interesting file, RC file. So till now, if you are working with the relational databases, you can see that your records are written. So let me open one. Okay. So say I have an employee table, again same employee table. Let's look at that. So if I have employee table, if I have employee name, employee department, employee ID, and so on. So if you remember your relational databases, your data is written something like this in the file. If you are writing this data into file, your data would be written something like this: name, then department, then ID, then name, then department, then ID, then name, department, ID, and so on. So this is your real file will look like something like this, right? But there are some problems with these files if I'm querying my data. So if I say I do a query, select from employee table, or say select employee name from employee table where employee ID is equals to 15. So I just want to, or say my query is select from employee table where department is equals to ID. I just want to select the name. But what is the problem with when I'm storing my data something like this in a columnar format? Sorry, in the row format, that is row by row. I have to do a seek on the whole row to reach the next name. So what this RC file format gives you is a benefit. On the benefit is we store data something like this. So they say this is my file, column 1, column 2, column 3, column 4, and the corresponding data for those columns in different rows. So first row starting, so this is your row number, this is your column number, this is your column number, row number, column number, and so on. So how this data is stored at the back end is something like this. So we divide this file in what first thing is horizontally. So we created 2 row groups of this file, and then we stored something like this, column by column, 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 column by column. So let me open an Excel sheet that will give you a more quick picture of. Oops. So let's say this is my employee table, employee name, employee department, and let's say employee ID, and address. Okay, so my data would be something like this: 1, 2, 3, 4, 5, 6, 7, 8. Some names. Some department. Whatever. What I pressed. Just a minute. So some department. And some addresses. Right. So this is how your file will be written at the back end. This, and then this, and then this, and then this, and then this. But what will happen in the row column format is you first break your files in a smaller subsets. So let's say we have defined it as 4 rows at a time. So you break your file at a smaller subsets. So these are 2 subsets of the file. These are called row groups. And then you store your data column wise. like this. So when I'm doing a select employee name from tables employee where department equals to IT, can anyone think of what are the different benefits I will get if I store my data like this rather than like this? And similarly for this thing also. Any guesses from anyone? What are the different benefits which I will get if I store my data something like this?
So can you get all of the, well, I guess I'm thinking of a Vodka database, which does things column-wise. So I'm thinking that with storage on the disk, it's better for in the Vodka case, but I don't know about here.
In storage,
column-wise store.
So on storage, yeah, definitely it's really helpful if I compress my data. So you can think of similar data could be compressed at faster pace, or it gives you faster compression. So if I'm storing it column wise, I have a similar data at the go, and that will really give me pretty good compression. And if it gives me pretty good compression, I am doing less IOs on the disk and my jobs will run faster. Secondly is I am doing less seeks. Why? Because when I have to read the name, because at a time on the table you will never read all the columns. You will be reading only some columns. So when I say I have to just read name, so I have to read on. I have to start seeking from here until here. Otherwise, what I have to do in such kind of file format, I have to seek from here and again from here, again from here, and again from here. Over there, at the one go, I can seek all these things. So my seek and read time is reduced, as well as my file gets pretty good compression. And why we divide them onto blocks, so that we do not so that our inserts and later on other inserts are good, and your data is also in the block format. So we divide the file into blocks, and we do, so these are called row groups. These blocks are called row groups, and we store the data column wise rather than row wise. And these RC formats would be really useful when you are dealing your data with Hive. So Hive basically helps you to read your data with the help of table structure. You can define tables on your data, on your files, and you can just run the query select from table so and so. So let's read this again. So this is what I told you right now. So horizontal and vertical partitioning of the table. How horizontal and how vertical? You first do horizontal partitioning. You divide them into row groups, and vertical, that is you vertically you basically transpose the columns. So you get both the partitioning on the tables. Horizontal partitioning will refer partition the table into multiple row groups, and the row size is always user defined. So these, how many rows need to be taken in a row group, that you can define. So this is row horizontal partitioning, and then you do a vertical partitioning on the data. So you store your data for each column at a single go. And this will really helpful for you when you are seeking the data, as well as this will give you pretty good compression on the data. So columns are compressed to reduce the storage space users, because that is similar data, that if the similar data is lying in parallel or at the go, that will give you pretty good compression. And everyone agrees to that part, right? How the compression happens is just based on zeros and one. So if you find similar zeros and one on your data, your compression on the file would be pretty good. And secondly, you do your seeks are pretty are reduced drastically, because at the go you will be reading only some columns on your file. At the time you will never be reading all the columns on the file. So this will be pretty useful if you are using some columns on the file, because you are drastically reducing your seeks. Someone muted me. Someone muted me, like, okay. So this is how you can pretty good these files are pretty good if you're dealing your data in the tabular format. So if, say, this is my data in the row oriented system, it will be looking something like this, where this is the separator for your row, and this is a separator for your data, and this is the row number. In your column oriented system, it will look something like this. So you have to remember that in this world, everything is in the file format. So at the end of the system, at the end of the day, you are storing everything in the files. So definitely there will be some separator for your column, there will be some separator for your rows, and this is how you will be reading the data and dealing with the data, or defining metadata on the data to define what is your row, what is your column, and how you. So that thing we will be doing on Hive part. But this file formats will be really beneficial for you when you are dealing with the data in Hive. Any questions on this RT file format? Okay, I assume no questions. ORC. ORC is a step ahead of RC. It is optimized row columnar. So ORC was row columnar. ORC is optimized row columnar. How that is helpful? So let's look at a file format that will give you an idea. So it not only contain your data, but it also contains some other data with your data, that is the metadata about the data. So it also contains index of the data. This index contains the information about your data, like what is the min and max values of different columns in the data, what kind of data is there in this row data. So if, say, I run a query, select employee name from employee table where employee ID is between 100 to 200. So what my program will do is just read this index data. This index will contain the min and max values of the employee ID. It will just check if the employee ID is lying between 100 and 200 in this row data. If not, it will skip the whole block. It will come to this next blocks. Just read the index data, and if it finds out the employee ID is lying between this and this in the index of the data, it will start reading the row data. Otherwise, it's again skip the whole block. So ORC is much faster than your RCs if your queries are something like this. So if you use that, they also contain index on your data, and this index is really helpful for you when you are doing the queries on the data. So ORC gives you much better performance as compared to RC in your Hive world. It also contains some other information like footer. So footer contains things like compression parameters and the size of the compressed footer and things like that. So, but what is useful is the index with the file. And by default, ORC is compressed with ZZ-zip. So if you just create ORC files, those are highly compressed, and they contain your data in blocks, so you don't have to reward splittability even though your file is compressed with ZZ-zip. Any questions? Does it make sense? Just ping me yes or no. Okay, sure. Mm. Preet, you can see your data is divided horizontally as well as vertically, as I told you in the RC file format. So similarly, your data is again divided over in vertically and horizontally. There are blocks. These are the blocks, and this is your real data. Let me use another color. Green. So this is your real data. Let me remove this lot of. So your data is divided horizontally, the green lines, and what is compressed is your data. This is your reset zip. 250 MB, small blocks. You can very easily deal them with your MapReduce code. You can again change your step size and everything. You can configure them. Avro. You will hear Avro a lot in the MapReduce world. So Avro files are basically used when you have to transfer your data between teams, or your data is, metadata of your data is changing a lot. What do I mean by metadata? So say today you have a data which of again say employee table. So a new field is added to your table, like say employee zip code. Tomorrow a new field is again added to your data, say employee um, laptop number, and after a month your some field is removed from the data. So your data is frequently changing. The metadata about your data is frequently changing. Or if you have to transfer your data between teams. So beauty with these files is they are self-describing. So the data is self-describing in these files for them. So one record might contain your employee laptop ID, another record might not contain because that was previously created. And you can read both the records pretty easily with the help of Avro files, as they contain metadata about your data in the data itself. So if today you are sharing your data with some other team where your Rappler ID is not yet there in the data, the team is not, the other team which is reading your data will never get affected, because the metadata with the data will tell that there is no laptop ID. Next day, when you are sharing your data with the team and you have added the laptop ID of the employee in the data, they will get to know with the metadata of the data, which is again shared with the data to the team. So they are self-describing files. They are splittable. They support different compressions and contain metadata section of your data. So another beauty about these files is when this dog cutting, if you remember the name which I told you in my first class, who's called to be father of the Hadoop core, who has created the Apache Hadoop. So when they were dealing with Hadoop, the data which was emitted out. But the problem with the so everything was written in Java only. For the data and all the code which these people were writing up. So when the Java objects were written into the file system, they cannot be read by any other language. So they were language dependent. And if they were language dependent, if those objects need to be transferred to some other users or some other teams which do not know Java, there was huge problem. So these Avro files basically overcome that problem. So these files are not only platform independent, these files are language independent also. So you can write them in Java, can read them with C#, you can write them with C++, you can read them with Python, and so on. So they can be processed by any of these languages. So they are not only platform independent, that is, if created on Unix cannot be read on Windows, they are also language independent. So these files are splittable. These files contain metadata with themselves. These files are language independent. These files are platform independent. They are compressible, they are splittable. Okay, so the next beauty which I was telling about is they contain the metadata. So if a new optional field is added to the schema, to read the old data, you can just read the data without changing your program code. So you don't have to change the code because your metadata is there with the data, and your older read program will never fail with your new data or with your old data, because while reading the data, you read the metadata from the data itself. So even if your fields are added or deleted from the data, these files are pretty useful if your metadata about your data is changing frequently. Does this thing make sense to you, or am I going a little faster? Sure, Sally, you can drop off. Okay. So this is the kind of different compression which I can achieve on the different files, and Parquet is again similar to RC files. So all these files, you don't have to worry about how they are stored at the backend, what they are done, but just remember the properties about these files. What are the different properties which you can achieve by these files, and while you'll be using them in Hive and Pig, then at that time they will make sense to you. So you can see the pretty high compression on the ORC files. Parquet is similar to RC files, so they again contain your data in the columnar form, row columnar format only. So these are the different data types available for Avro: long, float, double, bytes, string, and they contain complex data types also: array, map, enum, unions, all those things, similar to any other thing. So Avro gives you complex data types also, as well as normal data types also. So I am not showing the uses of these files. I'm not going to the Java code complexity, all those things. But all I want is you people is to remember the different compressions and the different file formats. In the next class, tomorrow's class, there is a Hive class. Most of these things will be really beneficial, and you will be using them when I'm talking in the Hive. So at that time, you will be really dealing with your data without the Java code, without anything, but by just using select start from table so and so, or select from table where so and so. So any questions on these file formats or compression? Sorry, Preet. What do you mean by site? Not one. Okay, 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 okay. So I think that will not make sense to start a new topic today. We'll start the new topic tomorrow only then. Puneet, for your problem, I'll give you a call personally and I'll resolve you. So Padmini, I hope you don't have any other question. So let's wind up for the day. We don't have much time to start a new topic. Let's start the Hive tomorrow only. Yeah, Padmini, I'll share the softwares with you. Sure, I'll do. I already shared. I don't know. Just you check your Gmail. That those are already shared, but I'll re-share them. Sure, sure. Thanks everyone for your time. Let's meet tomorrow, same time.